Bismillah ar-Rahman ar-Rahim. This is October 2007, paper 4, and the question of a topic of the rings. Okay, and first of all, what is the mass of the ring is a 4 kilograms. So naturally, what is a weight? Weight will act downwards. You can see clearly, and is a 4 times the 40 newtons force acting downwards. Okay, and this for if attention is for 60 degrees, so one is parallel to perpendicular to the rod, okay, and one parallel to the rod, because 60 is this one, because it's same. Okay, so which angle given is called cos component. So it's t cos 60, t sine 60. And I have discussed this before. Even this recording I'm repeat again. So whenever a rod is this way, okay, students, and you pull upwards or pull downwards, so this is R is acting always upward and is a weight mg weight. Okay, if tension is this way or this way. But when we talk about this rod is vertical, you're pulling upwards, R is inside. You're pulling this word, R is inside. Or one more diagram, if you pull not right side, if you pull left side, so R is inside. So always R is against the pull. So if this right side pull, so R is leftwards. If pull is leftward, R is rightwards. I think the point is very clear. So this same criteria I'm going to apply here, and I can tell you easily this is R. R. Some people think is R acting upward, not at all. This is only in the place on the surface or on the rod then. So then we can say it is upwards. So now first part is asking here, and common sense, because pull is downwards, so it will above, if it will move, weight is also supporting and force is also supporting, the friction will be 100% upwards. Okay, so now normal and friction component of the force ring we have to find in terms of T. So how we can find it? Right side force equal leftward force. So I can say easily R is equals to T sine 60. And T sine 60 is root 3 by 2. I'm writing exact. So root 3 over 2 T. This is my, I got the normal reaction. He was asking find normal reaction. And a friction force is equals to addition of these forces. So I hope so. The point is very clear. And 1 minute, please. Let me shift it up. And now I'm finding friction force. So friction force is basically equals to these two forces. So I can say T cos 60 and plus 40 t cos 60 is equal to sine 30, so this become half, so t over 2 or half t, I can write it half t plus 40. So I got a frictional force component as well. He was asking find out the normal and friction component of, okay, and in terms, and capital R or capital F he mentioned by, okay, I'm writing small f or E, all right, capital F, so no problem at all. Now he's asking further, next part he's asking find out the coefficient friction is given zero point 0.7, find out this one if it's about to slip. Common sense, about to slip, not in the downward, so friction is upward as we know it. So we can say what story we have, we can use these two equations solve the question. So I can include what is F? Frictional force is a half T plus 40. And what's friction force formula? Mu R. All of you familiar, mu R. And I'm going to complete, and R value is what? Root 3 over 2. Root 3 over 2t. So I'm writing here mu value is zero point 0.7, R is root 3 over 2t. And this value I'll bring here. So I'm bringing here half t equal to 40. From t, what is a common? What left here? Zero point 0.7 times 2 root 3 over 2 minus half equal to 40. Now I'm going to divide completely there and I will get my answer. So this I talk about 0 0.7 into root 3 by 2 minus half. So if I type in calculator, so let's see what answers turn to be. 0 0.7 times 2 root 3 divided by 2 and minus 0.5 or half and 40 divided by this. So I'm getting here 376.58. If I don't want, so round it, and I'm getting 377 newtons. So Alhamdulillah Rabbil Alameen, the question is completely over, and we have done this question.